Reciprocal trig functions, algebra 2 trigonometry regions. So the notes on top of your page are the reciprocal trig functions. I don't know, maybe you've been wondering this or maybe you haven't been. When we have a triangle with three sides, let me just throw a right triangle up here real quick for a demonstration. Um, we've been using sine, cosine, and tangent to pair 2 out of 3 sides, but there's more than 3 ways to pair 2 out of 3 sides. Like if I want to pair this, here we'll call this A, B, and C. If I want to pair A and C together, well, A over C, which would be, sine from this angle, right? But what about C over A? What if I wanted to do hypotenuse over opposite? Why does it have to be opposite over hypotenuse? And the answer is that it doesn't. So it's the reciprocal of opposite over hypotenuse, hypotenuse over opposite from this angle's perspective. But there's actually more than sine, cosine, and tangent. There's more ways to pair these 3 sides. And actually, if you had a little probability question here, like if you had 3 sides and you need to pick 2 of them, it would be 3 times 2 is 6. So the other options are, like adjacent over hypotenuse would be B over C. Well, we could do the ratio of hypotenuse over adjacent, the reciprocal of that, and tangent opposite over adjacent, pairing these 2 sides together. Well, why couldn't I just pair them as B over A? That would be adjacent over opposite. So there's really, to make a fraction from 2 sides of the 3 out of sides of a triangle, there's 6 ways to do it. You learn the basic sine, cosine, and tangent, right away, because those are, I guess, the ones we start off with. We call them the basic trig functions. But there are 3 others, and they are the reciprocal trig functions because they are the reciprocal of these. And so they have their own names. They're cosecant, secant, and cotangent. And basically, they're just the original ones flipped upside down. So first of all, if we talk about the reciprocal one at a time, the reciprocal of sine, 1 over sine, which is the reciprocal of something. Like if I have a fraction 2 over 5 and I do 1 over 2 over 5, it becomes 5 over 2 because you flip this and make it times the reciprocal of the bottom, 5 over 2, and so on and so on. But really, you're just going to memorize this stuff right here because at this point you have this memorized. You have sine, cosine, and tangent memorized for what they are. Now you need to just remember which reciprocal functions go with them, and so when you need to know them, you simply flip them upside down. So the reciprocal of sine is CSC, but it is the abbreviated CSC, but it's the word is cosecant. We say cosecant. Cosecant. Just like when we see cosine, we don't say cos, we say cosine, we abbreviate it. Even sine is abbreviated. There's actually an E at the end of sine. That's why some people call it sin by accident. But it is sine. There is an E, which is abbreviated. And this is cosine and tangent, but we just abbreviate it tan. Cosecant is abbreviated CSC. Secant, just without the co, is SEC. And cotangent is abbreviated COT. So co and then tangent. So secant, cosecant, and cotangent. And you may be noticing now that, well, cotangent is simply tangent with a co in front of it, and secant is related to cosecant somehow, and sine is related to cosine somehow, but that's something called cofunctions, and we're actually going to talk about that in another topic. So first thing that's a little bit counterintuitive is most people would guess that sine and secant go together because sine, secant kind of sounds alike, but it actually doesn't go that way. Sine goes with cosecant, cosine goes with secant. And so it's just one of those things that you just need to remember. Just like, when you're doing the sum of the roots, it's negative b over a. Like, you just have to remember it's kind of the opposite. Or if you're looking at the equation of a circle as x minus 3 squared, well, the coordinate is positive 3. It's kind of one of those where you just have to make a mental note now that it's not the one that you think it should sound like. Now, tangent and cotangent, they are reciprocals. They do go together. They do sound alike. They are what we call cofunctions. So it's easy to remember that cotangent goes with tangent. But cosecant and secant, you just have to make that mental note that the reciprocal of sine is cosecant. The reciprocal of cosine is regular secant. So when sine is opposite over hypotenuse, cosecant, hypotenuse over opposite. Cosine's adjacent over hypotenuse, secant's reciprocal, hypotenuse over adjacent. Tangent's opposite over adjacent, and cotangent, of course, is the reciprocal, adjacent over opposite. So let me give you an example. All right, so here we have an angle terminates through the point -4, 4 rad 3. Part A, state what quadrant the angle terminates. Well, if we have a negative x and a positive y, that must be in quadrant 2. All right, because we're looking at something like that. Draw a sketch. So, okay, so let's draw a little sketch over here. Quadrant 2 sketches we draw like this. Drop down our vertical line and label it. We know that the -4 is our x value, so that goes here. And the 4 rad 3 is the y value, which is the vertical segment. And we want to state all ratios of all 6. So we need to find this r value here, like we've been doing in the previous lecture. So a little Pythagorean theorem would be -4 squared plus 4 rad 3 squared equals r squared. That's going to be 16 plus 16 times 3, I believe, is 48. Check that on my calculator in a minute. 64 is r squared, and so r equals 8. So pretty confident my maths are right because it came out to be something nice and simple. So r is 8 here. And now remember, the angle we're using for perspective is always at the origin, so our angle theta is here. So that's going to mean that my opposite side is my y value, and it always works out that way. My hypotenuse we just found is 8, and my adjacent side is that -4. All right, so list all 3 functions. Well, first we'll start with the basic ones. Sine theta is opposite over hypotenuse, so that would be 4 rad 3 over 8, which can reduce down to, I can simplify the 4 over 8, so we'll say rad 3 over 2. Cosine theta adjacent over hypotenuse is -4 over 8, and that reduces down to -1/2. And tangent theta is opposite over adjacent, so that would be 4 rad 3 over -4, which I can simplify to simply be negative radical 3. Simplify 4 over -4 to be -1. So those are my 3 basic ones. And we did problems like this in the previous lecture, the previous class, where this tells me a quadrant, I draw a picture. Remember, you always draw the hypotenuse from coming out of the origin, and then that vertical line always goes to the x-axis, either down to the x-axis or up to the x-axis, either way. Label your x and y sides, Pythagorean theorem to find your hypotenuse. Bunch of stuff squared. And then your angle theta is always at that origin, and so opposite, adjacent, hypotenuse, and you got your functions. So now we're going to add the new ones. So the reciprocal of sine is cosecant. So CSC theta is simply sine upside down. So that would be 2 over radical 3, which I'm going to rationalize to be 2 radical 3 over 3. And we can't have a radical on the bottom down here. Secant theta is the reciprocal of cosine. So reciprocal of -1 over 2 is -2 over 1. Over 1 is optional, so I could just write it as -2. And the reciprocal of tangent is cotangent theta. And the reciprocal of negative rad 3, again, this is kind of like negative rad 3 over 1, would be -1 over radical 3, which is going to rationalize to be negative radical 3 over 3. So there's going to be a good amount of rationalizing denominators when one of your sides is a radical. But that's basically it. Notice that when I do a reciprocal, all I'm doing is flipping it upside down, rationalizing, simplifying if I need to. The signs don't change. Cosine here is negative. Well, the reciprocal secant is still negative. So we don't change the signs when we do reciprocals. We do like to keep the negative signs on top. Notice that I had -1 over 2 became -2 over 1. You can put that negative sign on the top, the bottom, the middle. I prefer to keep it on the top. It's a little bit more proper that way. But the sign, the fraction is still negative. It's simply just upside down as a reciprocal form. So this is it. This is basically what you're going to be doing. It's an extension of what you have. So like this next problem, I'm not going to do it, but you're going to do this in class where it says like find cosecant A. Your mentality needs to be, all right, well, that's the reciprocal of sine. So let me find sine A and then flip it upside down. Like very few people take the time to memorize that secant hypotenuse over adjacent. What we do is we memorize it's the reciprocal of cosine. So I think cosine and I think upside down. And so that's how you're going to approach these new trig functions. It's just a little bit of memorizing which one goes with which one.